All right, chapter 3, day 6. All right, we're now to a really cool prompt. Alcohol and heart disease. This is a fun one. It's sort of famous. We know that alcohol consumed from red wine is supposed to help with heart disease. It is an observational study, meaning that we can't really conclude cause effect because, different cultures have different habits. Like, maybe in Italy they drink a lot of wine, and maybe they also work a 30-hour week instead of a 40. That helps heart disease. Maybe in Italy they eat less red meat, which might also help. So there's all kinds of factors. Okay, so you can see I already put it in the calculator and got that. Okay, we know how to do that. You go stat edit, you go ahead and set it up, and then you go stat calc and then 8, because that's the one we want. L1, L2 is the setup. On some calculators, it's L1, L2. By the way, on the AP test, in my test, you'll never really be asked to use your calculator to get R and R squared. It just doesn't work that way because some kids don't have them, and we don't want to get into issues like that. So usually it's done through the mini tab printout so you can see them. So it ends up being pretty easy, really. But I like teaching kids how to do it because I think it's good for everybody. All right, so there is your A and there's your B. So you can see the B is negative, meaning for every liter you drink of alcohol per wine per year, the deaths go down about 24, 25 people per 100,000. Okay, it's kind of an awkward statistic. It's heart disease deaths per 100,000, so it's kind of a weird thing to write. But okay, so I've written that out down here in red, so you see that. And then if I can graph this thing, y equals, I'm going to go ahead and just type it in. It's 271.336 plus, actually, let me go back on that, minus 24.85x. Then x is up here. Okay. You can graph that, it'll come. So that's a really good looking line, and you can imagine the residual plot. And again, the residual plot, if you can imagine that, and I'm going to draw that out for you. So we're pretty far along here. So here's the residual plot. You turn the function on its side, and then all these points up here are like right here, right? Okay, and then these ones down here will be down here. But you can just kind of visualize it. A couple down there, a couple up there. What you end up having is this is randomly scattered. So it looks like a line. The residuals are randomly scattered. R squared is really high. It's 0.724. So you know that this is a pretty good fit for the data. All right. So the questions that we have, we'll go through a lot more than just the 3 that I asked. We got a bunch here. So this will be good review for you. Maybe you can do this orally this time. You might write it down. I'm not sure. Does alcohol from wine cause a reduction? That's a great question. And I want you maybe to highlight this because this is so common. They will always try to get you to bite on that because you cannot conclude cause if it's an observational study. I just wrote not necessarily, since this was not an experiment, merely an observational study. That's an important thing. If it's from an experiment, you can say, yes, it looks like you can conclude cause. But if it's not, you can't. A really common question. Okay, so let's go down to the next one. Would you recommend more alcohol to help with disease? How much and why? This is super open-ended, super open-ended. You could say yes. I put no more than 9 per year. What I did to get that, this is just a clever question. There's not much here, but I was thinking, what if we zeroed out the expected deaths from heart disease and just figured out how many liters that would be? 24.85, right? X plus 271.336. If you put 0 in for that, 0 means we're trying to just get rid of it. 0 is down here. So really what I want to know is what this number is. And it's 1, 2, 3, 4, 5, 6, 7, 8. Looks like it's about 9 or 10 somewhere. That's what I did. I think it's clever, but that's not necessarily the answer. It's just a clever question. So when you solve this, let me go ahead and solve this problem. I'm going to go stat. Let's see here. Second quit. So basically, it's ends up being 271.336 divided by 24.85. If you solve that little algebra problem, you'll get around 9, I think. 10, I guess 10.9, yeah. Around 9, 10.9. I mean, that was the exact answer. I was just kind of eyeballing it for that one. Okay. But, you know, I guess you could recommend more, but, you know, don't go crazy because it seems to zero out there. All right. Explain in your own words the difference between correlation and causation. Okay. Correlation suggests a pattern that exists or evidence, while causation is a more powerful statement that in one variable essentially creates the other results. You may want to say this: causation can only be established by an experiment. You might want to add that as well. So that's just what we did there. But what I'm going to do now, just verbally, and if you want to write it down, you can. You may consider turning this piece of paper over and writing down. We're going to go through our typical questions. Those typical questions are right here. Okay, so here we go. What does R mean? R and R squared. So let's go through number 1 and 2, R and R squared. We've done that before. Okay, so there's R, negative 0.851. Okay, here we go. So if you want to write this down, you can. There is a strong negative linear association between alcohol from wine and heart disease per 100,000, or just say heart disease. Okay, so there's one. Question 2 is, what does R squared mean? And by the way, the name of R is the correlation coefficient. What does R squared mean? R squared is a percentage. Its name is the coefficient of determination. So this is 72.4% of the variability in heart disease deaths is due to the amount of alcohol from wine you drink. Kind of an awkward statement, but that's a pretty big percentage. Okay, so that's number 1 and 2. Okay, number 3 is, what is the equation of the least squares regression line? Define all variables. Okay, that's number 3, if you remember that one. All right, so here's the equation. I will get that highlighted for you, underline that in blue. Here's the equation. So you have to also write out what X and Y are. X is alcohol from wine. Y hat is predicted heart disease deaths per 100,000. Put the word predicted in there. Okay, so there's that one. Number 4, place a value in X to produce a Y, no problem. So we want to be in the domain of study. So this particular study goes from like 0.7 to 9.1 is the high. So let's just say 8. What is the predicted amount of heart disease deaths if the country per person consumes about 8 liters of wine per year? Let's put an 8 in there, no problem. Okay, so we're going to go negative 24.85 times 8 plus 271.336. Okay, and it's about 72 heart disease deaths per year. That's about right, because 9.1 was, I'll sort of highlight that one for you, because 9.1 right here produced 71. So that's about right. Okay, good. The other one is, let's say you wanted to reduce heart disease deaths to 50 per year in a culture, 50 per year. So what we're going to do is we're going to put 50 in for Y hat. So put 50 in for that, and then we're going to solve for X. So let's go ahead and do that one. Okay, so we clear this. So if we go 50 in for Y hat, we would then go 50 using algebra minus 271.336 336, and then divide that by 24.85. And we get about, how's that? You could actually, it's impossible. That's extrapolation. You can't get it that low. It would be, did I do something wrong there? 224 negative. Oh yeah, divided by times -1. Whoops, I forgot to. There we go. It's about 8.9. Sorry, I forgot the negative there. 8.9. So 8.9 liters of wine will get you down to about 50 deaths. Okay. So there's those two. Sorry how poorly I did that one. What does a slope mean in context? What's its value? All right, the slope. Here's the slope right here. Negative 24.85. That means a decrease. So it's a for every statement. For every liter of wine consumed per year in a culture, the heart disease deaths is predicted to decrease by 24.85. A good little marketing campaign for the makers of wine. Okay. All right. Next one. What's the formula that involves slope, correlation, and standard deviation? No problem at all. That is B equals R times S sub Y over S sub X. You're going to run into that in your homework. We're going to run into that maybe in some practice questions that I'll give you later. So we'll see that. Okay. All right. What does resistant and non-resistant mean? Name things that are non-resistant. Remember, the slope is non-resistant to an outlier. So let me again put this up here. Zoom 9. If a point came in, I'll get a red. If a point came in like right here, some weird point, that would severely change the slope because the line would move toward it and it would change it. Okay. R and R squared are also very non-resistant. They will move quite a lot when you get a point like this in there. Okay. All right. Now remember a point that's called an influential point. Let's say there was something way out here that was right on the line. That will not change the slope, but will increase R and R squared. Remember that one too. Okay. Is the line a good fit for the data? There's three things you got to focus on. One, does it look linear? It does. Two, if there was a residual plot available, or if you wanted to make one real quick, which I can do, I'll make a little residual plot. Okay, I'm just going to put the points, how they seem to fit in relation to that line. Here's a couple down here, a couple up there. That looks randomly scattered for the most part, no pattern. Two, and the third thing is R squared or R high. Yes, they are. What's the definition of high? The definition of high for R squared and R, 0.8 is high for R, 0.64, which is 0.8 squared, is high for R squared. Okay. What does an outlier influence in the problem? An outlier will dramatically change. The slope, R and R squared. And by the way, the meaning of least squares I forgot to do. Meaning of least squares. This line minimizes the sum of the squared residuals. Remember, the residuals are all these vertical gaps between the prediction line and what actually happened. Those vertical gaps, the ones on top are positive. The ones on the bottom are negative. They add up to 0. But if you square them all, they all become positive, and then you get a value. And that line minimizes the sum of the squared residuals. Okay. I talked about an influential point already. Let's talk about S. So S will be, it'll be a number given all the time. You'll never have to calculate it. Let's say S is 4. Okay. What S is, it's basically the average residual. The average residual if you take it in an absolute value form. That's basically what S is. Okay. So S in this case is 4. Okay, and what does that mean? That means the typical prediction is off by about 4 heart disease deaths per year. S will always be given. You'll never have to calculate it. Okay. All right. That is a very easy lesson for the day. Okay. I hope you're getting the hang of this because we're doing it a lot repeatedly. Okay. So that is where are we at here? That is chapter 3, day 6. Thank you very much.